Okay. All right. Oh, goodness gracious. All right, so make sure you have these things on your note card here, and let's see about it. All right, find angle C. So this is side, 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 so I cannot use my sine rule unless I have an angle and a side across from it. So I'm just going to be going ahead and doing the cosine rule. But I'm looking for angle C, so I'm going to change that right there to a C. So C squared would be 17 squared. And I got the other two side, 15 squared plus 10 squared minus 2, 15 and 10. And then cosine of C, right? Yes. All right, so let's solve this for cosine C. So I get 17 squared minus 15 squared and 10 squared divided by the negative 2, 15 and 10 equals cosine of C. So we're just going to have to put that in our calculator. So I'm going to be doing second cosine of that yucky fraction there. So I'll be doing inverse cosine of 17 squared minus 15 squared minus 10 squared over negative 2 times 15 times 10. All right, and make sure my calculator is in degrees. And it comes out to 83.1 degrees. All right, and then find the area of the triangle. So we just found out that this is 83.1 degrees. So the area of my triangle, I mean, I could do either one. I could do this formula because I could do 1/2 AB sine C. So, I could do these two, and then here's my C right there, because it's made for side angle side. Or I could use this formula, because it involves the three sides. But since I found angle C, I think I'm going to use the red one up there. My area is 1/2, 15, because it's just easier. And then 10, and then sine of 83.1. All right, so I will just do 0.5 times 15 times 10 times the sine of the last answer in my calculator. That comes out to 74.5. And it is in feet, so I'll say feet squared, or square feet. Okay, but again, you could have used the purple formula as well. All right, so number 14, find the measure of angle P pictured. So also find the area, yeah. All right, so let's go ahead and do the area up here with that other formula, because I think that was probably the plan. I don't know. Let's see, I forget. So S would have been 15 plus 10 plus 17, right? So that would have been 42 over 2, so that would have been 21. So if you would have used that other formula, you would have had the square root of 21 times 21 minus 15, well, 21 minus 15 is 6, times 21 minus 10, that's 11, times 21 minus 17, that's 4. So if you did that one, you would have the square root of 21 times 6 times 11 times 4, and hey, guess what? 74.5 feet squared. All right, anyway. All right, so number 14, find the measure of P. All right, so look at this right here. I got a side and I got an angle. And so I can use sine rule. Now, is this angle side side? No, it's not. It's actually angle angle side. So I don't have to worry about two triangle scenarios. So I can just do sine rule and go about my business. So 21 over the sine of 95 equals P over the sine of 32. Okay, so a little cross multiplying. So I get 21 sine 32 equals sine 95 times P. So I'm going to divide that by sine 95. All right, so just get that put in your calculator. Let's see. I got 21 sine 32. Make sure you're in degrees, but you probably still are. And sine 95. All right, 11.2, let's say. And that's it. Find the measure of angle P. So this is 11.2. And let's see, I can figure out that third angle, so 180 minus 32 minus 95. And this third angle is 53. And that way, if I want to find my area, I can just do 1/2 11.2 times 21 times the sine of 53. Okay, and then that's a lot easier than finding the third side. So 0.5 times 11.2 times 21 sine of 53. Okay, 93.9 units squared. All right, so number 15, I'll solve the triangle. So it did not give me a picture. I'm just going to draw an angle that looks like it's like 24 degrees. That's going to be my D. I'm just going to complete this, what, D, E, and F. All right, so D, across from D is 12. And let's see, D, I'll call this one E, and this one F. And so F is 16. All right, there's angle side side. Boo, right? So I'm just going to go ahead and use my sine rule, and I'm going to immediately try for a second triangle. It might work, it might not. The first triangle might not work, but we'll see. All right, so I got 12 over the sine of 24 equals 16 over the sine of F. So when I cross multiply, I get 12 sine of F equals 16 sine 24. So sine of F equals 16 sine 24 over 12. So let's see, let me make a fraction. Oopsie. 16 sine 24 over 12. This comes out to a decimal less than 1, so I can do this. So F equals, I'm going to do the second sine of that last answer, and I get 32.8. All right, so let me try for alternate F. Alternate F would be 180 minus 32.8. So 180 minus 32.8 is 147.2. All right, so let me start a list. I got D, oh, why did I do that? I got D, E, and F. Alternate D, alternate E. Why did I write that? Oh my God. Oh, E, alternate F. All right, so let's see if we even have a triangle. So D was given as 24, and so that's going to stay 24. All right, I just found F to be 32.8. So if I do 180 minus 32.8 minus 24, that means that this is 123.2. All right, there's my first triangle. All right, so let's see. Alternate F, we got to be 147.2. So let's do 180 minus 147.2 minus 24. Oh, and I do get 8.8. So there is space for another triangle. All right, so now we need D, E, and F, and alternate D, alternate E, alternate F. All right, well, I was given D and F. So D is 12, F is 16. So these can't change. It's just E. All right, so let's do E. Let's use this guy right here since I was given that. So 12 over the sine of 24, 24 equals, let's find E over the sine of, and in this scenario, E is 123.2. All right, so do your cross multiplying. Let's do 12 times the sine of 123.2. And then we're going to divide that by sine of 24. 24.7. All right, so 24.7 centimeters. And then over here, I need 12 again over the sine of 24. This time E over the sine of 8.8. So I'm using this guy. All right, so 12 sine 8.8 divided by sine 24. So E in that case is 4.5. So 4.5. So this is the worst possible scenario, but oh well. All right, so remember what would have happened if you didn't have a triangle at all, this wouldn't have worked. You wouldn't have been able to get an answer. If you didn't have two triangles, that means that when you found this answer right here, that this angle and this angle would have added up to more than 180, so you couldn't get a third angle. Okay, so if it happens, it happens. If not, it not. All right, let's do a few graphs here. So let's see. So remember, to graph something to on your calculator, you want your calculator in radians, and you want to do zoom 7. The zoom 7 is like your trig picture. All right, anyway, reflection, no. Oops. Amplitude 3, period. Period, I would say 2 pi over this 2 right here. So the period is pi. And, you know, to see everything nicely, we need to factor this out. If I take out a 2, that would be x minus pi. So that's going to let me know that my horizontal shift is to the right by pi. My vertical shift is up 2. All right, so let's go ahead, you know, on this next page, or down below, sorry. I'm going to make a graph like this. It's numbered by pi over 2's. All right, why did I, uh-oh. What did I just do? Oh, I created another, okay, there it is, sorry. All right, so let's go ahead and make a graph here. All right, and amplitude is 3 and went in up 2. So up 2 is my center, so that's my new center. And I'm going to go 3 up and 3 down. So 2, 3, 4, 5. So that's my spot there. 1, 2, 3, right here. So right here and right here are like my lows and my highs, right? But remember, this is cosecant, so it's going to go, they're going to be like parabolas up here and parabolas down there, right? Okay. So I do expect this to be squished in more together, but let's go ahead and number the axes here. So I got pi over 2, pi, 3 pi over 2, and 2 pi. All right, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. All right, so now let's go ahead and think about the graph and where the asymptotes are. So cosecant goes with sine. Sine looks like this. So the asymptotes are going to be here, here, and here. So on the original graph, so 0 and 2 pi are my outer boundaries for my original 2 asymptotes of cosecant. So I'm going to take 2x. Ooh, let me not do this here. I'm going to take 2x, 2x minus 2 pi, put it between 0 and 2 pi. All right, so let's see, add 2 pi. So I get 2 pi here. Get 4 pi. Divide by 2, so I get pi and 2 pi. All right, so pi and 2 pi are the outer 2 asymptotes. So I'm going to have an asymptote here at pi and at 2 pi. But remember, this is the outer part. I need this little asymptote in the middle as well. So I'm actually going to have an asymptote here as well. So my first 2 graphs here would be up and down. So it's going to appear right there, facing up, and right here, facing down. Right, and then you would just go and, you know, complete the pattern here. So here, that means my graph is going to be facing down there, and then continue it on. So basically every line, and you would just want to be able to go to negative 2 pi, you know, basically do it over here as well. Okay. All right, so tangent. So let's figure out our stuff here. Do I have a reflection? Yes, I do. A vertical shift, I'm going down 4. Amplitude It's no amplitude change, or it's just 1. The period is normally pi, but it's over this 1/3 in front of my x. So my period is now 3 pi, and horizontal shift, none. All right, so let's figure out where my asymptotes are. So remember, tangent normally is right between here, and it's going up like this. So negative pi over 2 and positive pi over 2. So I'm going to take x over 3 and put it between negative pi over 2 and positive pi over 2. So multiply everything by 3, and I get 3 pi over 2 negative, and 3 pi over 2. All right, so when doing my graph, I just have to make sure I go down 3 or 4. So there I am there. And if I number pi over 2, pi, 3 pi over 2, 2 pi, and same thing over here. All right. My asymptotes are negative 3 pi over 2, positive 3 pi over 2. And I'm just going to draw a tangent, but upside down. So it's going to be my center right here. So it's going to come down here and go over. And if you needed to, you would just count out, you can see here that you got like 6 spaces right here. You just count 6 more spaces this way and 6 more spaces that way. And if you needed to draw it again, you'd draw it again over there and draw it again over here. Okay? All right, last one here. So fill out the information below and write a graph of a secant. So let me remember what secant looks like. So secant is the reverse of cosine. Cosine looks like this, right? Like that. So secant must have been up here and down here. His asymptotes used to be at negative pi over 2 and positive 3 pi over 2. All right, so let's see. Amplitude and vertical shift. So I can tell here, let's see, 2 and 4. That's a space of 6. So that means 1, 2, 3. Here's my center. That means that this graph got moved down 1. So vertical shift is down 1. All right. I can also tell that it got stretched. So 1, 2, 3. So the amplitude is 3. Let's see, the horizontal shift, we'll take care of that in a minute. Let's see. So the period. So the period of this thing, if I look at these graphs, there's 1 down and 1 up in a space from 0 to pi. So the period is pi. That means that 2 pi over b has to be pi. So that means that b must have been 2. Because 2 over 2 cancels out and you get that. So 2. All right, so let's see. If I did that, if the period got switched to pi, all right, so let's see, this is going to be a little bit tricky here. So basically everything that was happening in 2 pi is now happening in a space of pi. So let me start writing my equation. So y equals, because I'm trying to figure out my horizontal shift here. Okay, actually, I can figure this out. Sorry, I was having a moment. So you see how this right here used to be at 0, like it used to be right above 0 right here? And look at how it is now over here. So we're going to see if this will do it for us. We're going to shift it to the left half that distance there. So that would be, instead of pi over 2, pi over 4. So let's try this. Left, pi over 4. And then we'll check our answer just to make sure we're right. All right, so let's write our equation. Oh, let's see. I want 3. I want my b value, so I want secant. 2, left pi over 4, so x plus pi over 4. And down 1. so -1. Okay, so let's check these asymptotes, these two right here. So I have 2x plus pi over 4. Let's put that between the original asymptotes that I knew were there to start with. So negative pi over 2 and positive 3 pi over 2. So let's divide everything by 2. So that would be like multiplying by 1/2. So I get negative pi over 4. And then x plus pi over 4 would be here now. And then I would get 3 pi over 4. Now let's take away pi over 4. So take away pi over 4. So that would be negative 2 pi over 4. And this would be 3 pi over 4 minus pi over 4 would be 2 pi over 4. So that would turn into negative pi over 2 and positive pi over 2. So, yep, look at that. Negative pi over 2, positive pi over 2. Those can be my first two asymptotes. And then, like if I was graphing this, and then there's the next one, I would cut that space in half. Okay, so we are correct. And there is our equation. Now, of course, you could have, this part right here, this could have been different, but everything else should match. You could have a different shift, but horizontal shift, but I don't know, that's just the one I noticed. We could have also gone to the right by 3 pi over 4, but it's just easier to do this one, I think. All right, that's it.